Okay, this is the ordinary level, 2015, question 7. Okay, so explain the term resonance. Okay, so resonance is the transfer of energy from a wave to an object with a similar natural frequency. Okay, the transfer of energy from a wave to an object with a similar natural frequency. Great. Part 2. Describe a laboratory experiment to demonstrate resonance. Okay, there's a couple of ways we have of doing this. One is Barton's pendulums. Describe. Okay, so the one that I quite like is if you have a retort stand and then a string and then another retort stand. I know it doesn't say with the aid of a label diagram, but I just want to explain it to you. And then we have pendulums of different lengths. We call that L1, that L2, that L1, and this one L2. And then we say set up pendulums of, let's just go with similar lengths, hanging from the same string. Set one pendulum oscillating or swinging. Other pendulums with similar lengths will begin oscillating. 2. The idea here is that if anything else has got L1 and L1, they will start swinging together. And then if you have L2 with L2, they won't start swinging if L1 is swinging. But if you start this L2 swinging, this L2 will swing as well. And the L1s won't because they're not a similar frequency. Okay. Other pendulums with similar lengths, I guess we probably should have said, and some different lengths as well. And then what do we say? Energy is transferred between pendulums with similar natural frequencies. Okay. The other one that we can talk about is where you have two tuning forks and you strike one tuning fork and place it near another tuning fork, and the second tuning fork will start to vibrate as well. Okay, so the diagram shows a wave form. What is length A called? And just for the solution, I will draw it so you can see. So we're going, and we had this length A and this length B. Okay, so A is equal to the wavelength. B is the amplitude. Remember, the amplitude is the half, the full up and down. It's from the undisturbed location to the maximum. What is meant by the frequency of the wave? So frequency, can you still see this? You can, is the number of waves, but they usually like the word cycles, that pass a point in 1 second. List the 3 characteristics of a musical note. Okay. Pitch, which is frequency, loudness, which is amplitude, and what's the last one? It's the overtones, quality. Right. So quality, or I think in music is it timbre, they call it. It's the number of overtones that are present. Okay. What is meant by the natural frequency of an object? It is the frequency at which the object will vibrate if free to do so. So everything can have a natural frequency. The natural frequency of a strict string is 250 hertz. Write down what we know. Calculate the wavelength of the sound produced. Okay, and we're told that the speed of sound in air is 340 meters per second. Okay, so we have a formula for this. It is that C is equal to F lambda, or lambda F if you want. So we're looking for lambda, so rearranging that, I get lambda is equal to C over F. So I get 340 divided by 250. And I get 1.36, what am I looking for, wavelengths, meters. Okay.